Have you ever wondered how stars live and die? Our journey begins with nebulae, vast clouds of gas and dust that drift through the cosmos. These aren't just any old clouds, though. They're celestial nurseries, the birthplaces of stars. Under the influence of gravity, these nebulae collapse in on themselves, creating pockets of dense material. These pockets are the seeds of stars known as protostars. Protostars are a bit like infants, growing as they accumulate more and more material from their surrounding nebula. As they grow, they heat up, setting the stage for a dramatic transformation. When their core temperature reaches a staggering 10 million degrees, nuclear fusion begins. Hydrogen atoms smash together to form helium, releasing energy in the process. This is the spark of life for a star, the moment when it starts to shine. Welcome to the main sequence stage, where a star will spend the majority of its life. This is the prime of a star's life, akin to adulthood in human terms. Here it's all about balance. The inward pull of gravity is perfectly counteracted by the outward push of energy from nuclear fusion. This delicate balance keeps the star stable, allowing it to shine for billions of years. During this time, the star is a cosmic powerhouse, converting millions of tons of hydrogen into helium every second. This process, known as nucleosynthesis, is responsible for creating the elements that make up the world around us. Everything from the iron in our blood to the silicon in our computers was once forged in the heart of a star. So, stars are born from dust and spend their lives burning brightly in the sky. But what happens when the fuel runs out? Tune in for the next scene to uncover the spectacular finale of a star's existence. When a star has no more fuel to burn, it begins to die. But did you know that the way a star dies depends on its mass? Let's delve into the fascinating world of cosmic finales. Stars, like us, have a lifespan, and when they exhaust their nuclear fuel, they face their inevitable demise. But the manner of their death is as unique as they are, dictated by their mass. Low-mass stars, those with less than about half the mass of our Sun, meet rather humble ends. As their nuclear fuel gets depleted, they swell into red giants, casting off their outer layers into space. This creates a beautifully vibrant cosmic spectacle known as a planetary nebula. What remains of the star shrinks down to a hot, dense core, a white dwarf. Over billions of years, these white dwarfs cool down. Their glow fades, and they transition into black dwarfs. Picture a once vibrant star, now a silent, lightless orb in the vast cosmic expanse. Now let's turn to the high-mass stars, the ones with more than 8 times the mass of our Sun. Their deaths are anything but quiet. As their nuclear fuel runs out, the inward pull of gravity takes over, causing the star to collapse under its own weight. This triggers a violent explosion, a supernova, outshining entire galaxies for a brief moment. The aftermath of this cosmic detonation can lead to 2 possible outcomes. If the star is massive enough, it can collapse to form a neutron star, an incredibly dense object with a teaspoon of its matter weighing as much as a mountain. But if the star is truly colossal, its fate is even more intriguing. It collapses into a point of infinite density, a black hole, where the laws of physics as we know them cease to exist. Whether they fade away quietly or go out with a bang, all stars eventually meet their end. Each star's death, though a cosmic finale, is also the beginning of something new, a testament to the continual cycle of cosmic life and death. Now that we know how stars live and die, let's delve into some surprising facts about these celestial bodies. Fact number 10. Did you know that stars aren't actually twinkling? The atmospheric turbulence of Earth makes it seem as if stars are twinkling when in reality they're not. Moving on to fact number 9, the number of stars in the universe is staggering. It's been estimated that there are around 100 billion galaxies in the universe, each containing an average of 100 to 200 billion stars. That's more stars than all the grains of sand on Earth. Fact number 8, stars aren't all the same color. Their color depends on their temperature. The hottest stars are blue, while the cooler ones are red. Our Sun, which is a yellow star, sits somewhere in the middle. For fact number 7, let's talk about size. The smallest stars, known as red dwarfs, are less than half the size of our Sun. On the other hand, the largest stars, called red supergiants, can be over 1,000 times bigger than our Sun. Fact number 6. Stars are not stationary. They're constantly moving through space at incredible speeds. Our Sun, for example, is moving at roughly 450,000 miles per hour. Halfway through our countdown at fact number 5, stars are the universe's factories. Through a process called nucleosynthesis, they produce nearly all of the naturally occurring elements on the periodic table. Fact number 4, the brightest star in the night sky is Sirius, also known as the dog star, but it's not the most luminous. That title goes to the pistol star, which is so bright that if it were as close to us as Sirius, it would cast shadows at night. On to fact number 3. The oldest known star is over 13 billion years old. Named Methuselah, it's nearly as old as the universe itself. Fact number 2. A neutron star, the remnant of a star that has undergone a supernova explosion, is so dense that a teaspoon of its material would weigh about 1 billion tons on Earth. And finally, our number 1 surprising fact about stars. They're not silent. Stars vibrate, creating a humming sound that can be detected with special instruments. This is known as stellar seismology, and it helps astronomers understand the internal structure of stars. Stars are not just points of light in the night sky, they are fascinating and complex objects with many surprising features. We hope you enjoyed learning about the life cycle of stars and some surprising facts about these celestial bodies. The universe is vast and filled with wonders that can boggle the mind, and we're here to help make sense of it all. If you found this journey through the cosmos fascinating, why not become part of our community? Subscribe to our channel and you'll never miss an opportunity to delve deeper into the mysteries of the universe. Give us a thumbs up if you liked this video. Your likes tell us we're on the right track and they help others discover our content. Got a question or a comment? Don't be shy. We love hearing from you. Your insights and inquiries fuel our content and keep us inspired. And why not share this video? You never know who might be sparked by the wonder of the stars. Thank you for watching. Stay curious and keep exploring the universe. Let's quickly recap what we've learned about the life cycle of stars. We began our journey with the birth and life of stars, where we discovered the fascinating process of nucleosynthesis, the forging of new elements within the heart of a star. Moving on, we delved into the end of a star's life, a dramatic event that can lead to a supernova, a neutron star, or even a black hole. The 10 surprising facts we've uncovered opened our eyes to the sheer diversity and complexity of these celestial bodies. From the fact that our own Sun is a middle-aged star, to the intriguing reality that the color of a star can tell us its temperature and age. And now we're here at the end of our stellar journey. It's been a fascinating ride, hasn't it? So the next time you look up at the night sky, remember that each star has its own unique story to tell.